Here's something that comes up a lot in counting, so we want to be pretty good at this. It's called factorials. Do it by an example. Suppose that we have 5 objects and we're going to put them into a row. So I'll draw it here. Here's how I think about it. 1, 2, 3, 4, 5. So I've got the leftmost object and the next one, and then finally the rightmost objects. So how many ways can I do this? How many choices do you have for that leftmost position? Yeah, you could put any of those 5 objects there. And then what about in the position next to it? Well, there's only 4 left, right? You already used 1, so there's 4 objects left. And then this position right here, there's 5 to begin with. You've used 2, so there's 3 left. And then likewise, 2 and 1. Multiplication principle says we're going to multiply those together. So what you get is 5 times 4 times 3 times 2 times 1. Now, instead of writing this is a little inconvenient, but look what it does. It starts at 5 and goes consecutively down to 1 through the integers. So we have a notation for this. I'm going to write this. I'm going to write 5. That's the number at which it starts. And then to indicate that it just multiplies all the way down to 1, you put an exclamation point. And the way you read it is 5 factorial, right? 5 factorial. Now, these factorials, they can get big fast, and it's kind of hard to realize what they really are. Let's just start here. Now, I'm going to start back here with a 0 factorial. We'll come and get this one later. But what is 1 factorial? Well, 1 factorial is just 1 times 1, which is 1. 2 factorial. That's 2 times 1, which is 2. 3 factorial. Well, that's going to be 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, which is 24. Now look what happened here. We popped up very quickly. We were at 1, and then it doubled to 2, and then it went up to 6, and then suddenly it's up at 24. Now that we're looking at a 1, and the 2, not much of a change. 3, not much of a change. 4, not much of a change. But look at the big changes in the factorial. Do another one here. What about our 5 factorial? That's 5 times 4 times 3 times 2 times 1. But notice this. You see that part right there? That's 4 factorial. And then I've got the 5 times 4 factorial. Now here's what that tells me. If you read the notation, it says 5 factorial is 5 times as big as 4 factorial. Right? Just read what you write. 5 factorial is 5 times as big as 4 factorial. Now that turns out to be 120. And sure enough, if you go from 4 factorial to 5 factorial, what did you do? You just went 5 times as much, right? So it may not look like much because your eye is just looking at the integers without the multiplication. So these things go up fast. Look at 6 factorial. If I can write it here. 6 factorial, well, that's going to be 6 times 5, 4, 3, 2, 1. But look at that part right there, just so we can see. 6 times 5, 4, 3, 2, 1 is 5 factorial. So that means that 6 factorial is 6 times as big as 5 factorial. And that turns out to be 720. And sure enough, 120 times 6 is 720. So look what happened here. We were at 5 factorial and we were down at 120. We just went up 1 integer more to 6 factorial, and we're all the way up now to 720 factorial. Now if you have a TI calculator, here's how you can compute these factorials. Type in 8, then press the math key. The math key is in the left column near the top, 3rd or 4th row. Type in 8, press math, then arrow over is right at the right-hand side to the menu item says PRB for probability. So type in 8, press math, arrow over to PRB, and then you'll see this one down here is item number 4. So you want to select this. So you can either scroll down to 4 with your arrow keys and press enter, or just type in the numerical number 4, right? Just the number 4. And then press enter. And when you do that, you will see the number 4, well, if I can write it here, 40320. So what do you get? 8 factorial is 40,320. Now look what happened back here. We were at 6 factorial and we were only at 720. You just go up 2 numbers and you're already at 40,000. Now let's look at 0 factorial, okay? What is 0 factorial. To get an idea, look what we were doing down here before. We were taking like 5 factorial, and we broke it to 5 and then 4 factorial, right? 5, 4 factorial. And then we took, 6 and broke it into 6 times 5 factorial. So what if we write this in general where we had something like this? Suppose you start with some number n, and you want that factorial. So what do? You write the number n, and then you multiply it by, well, by what? Look what you did. You start with that number n, and then you write it with a factorial of 1 below it, right? 5, and then the 1 below it. 6. You write a 6, and then factorial 1 below it. So if I start with n factorial, I'll write the n, and then 1 below it factorial. So this will be n minus 1 factorial. Now what if I start here with this? I'm going to get to the 0 factorial. What if I start with this one? 1 factorial. Well, we know that to be 1. But according to our formula, what we could write is this. 1 factorial is you start at your number and then multiply it by the 1 just below that times what? 1 minus 1 factorial, or 1 times 0 factorial. So here's where we are. 1 factorial is equal to 1 times 0 factorial. 1 factorial here, that side is 1, equals 1 times 0 factorial. Now if you divide both sides by 1, you get 1 over 1 is 0 factorial. So 0 factorial is equal to 1. All right, so we're now going to make a definition. 0 factorial is equal to 1. Now look, if you understood this little proof here, that's great. If you didn't, don't worry about it. You just need to know in our counting that when you hit 0 factorial, that's a 1. And there's a good reason for it. And here's that suggestion. So I'm just going to put that all the way back over here. All the way back over here. For 0 factorial, I'm just going to write that as a 1.